Hello, I want to start off by thanking you for the opportunity to present this project. We decided to do the drone route optimization. We are Team Microsoft Bestxcel, and my name is Luke Morazzo.
I'm Shanshan.
I'm Kelly.
And running camera is our wonderful teammate Corey Johnson. As a brief introduction to this project, we really tried to look at the question first. So the question was, what is the most efficient route that Gamecock drone services can take to their 125 unique locations or cities so that we can minimize total distance travel? This is really an efficiency question, trying to minimize how far this company is traveling with these packages. And we really tried to look at it with three distinct methods. We first tried the nearest neighbor method using Excel. We then went on to do cluster analysis using depot assignment using both Excel and Tableau for the visualization. And finally, we ended with two-op method using R. This first graph here is just a basic visualization spatially of where all the 25 unique cities are. As you can see some basic clusters around 40 on the x-axis and around 40 on the y-axis, but that's something that we knew we'd have to investigate further. We pointed out three distinct cities that are kind of on the outline, on the farther reaches at 99, 17.3, and 499.
So the first method that we use is called nearest neighbor in Excel. As you can see, our headquarters is 1, 1. So first of all, we calculate the nearest point to our headquarters 1, 1. In this case, it's 3, 4. And then, so we use the Excel worksheet to calculate the distance from 1, 1 to 3, 4. And then we start from 3, 4 as our new headquarters, and then do that over and over again. So, as you can see from this worksheet here, that's the last few points that we calculate. And then after we calculate the end point, which is 499, and we have to back to the headquarters 1, 1. So that distance is 98 miles. So we add them all up. The total distance is 852 miles.
So the second method that we did was cluster analysis, and again, we also did this using Excel. Specifically, we used a solver within Excel. And so for this, we were using depot assignment to generate different clusters around a central point, and in the end, we ended up having 25 different clusters. So if you look at this data graph here, or not graph, but sort of analytical spreadsheet, here we have the total distance and then the number of cities in each cluster. And in the end, this actually didn't end up being super effective for us. Our distance actually increased to 1,012.97 miles, which is obviously larger than what we had initially gotten using the previous method. And this is a data visualization using Tableau of the cluster method that I just talked about. So each cluster has a different color, and as you can see with these, the clusters tend to overlap, and you can see especially with the outliers, they're not really set in clusters, and here especially you can see overlap in these other areas here. So really it just wasn't an effective way to look at our data set.
The final method that we used was the two-op method. We really tried to see with each method that we did that there was this major overlap. As Kelly mentioned, the clusters were kind of all over the place. There was some overlap with one unit was with one cluster even though it was closer to another one. And what we realized that with this overlap, we had to find a method where we would minimize that overlap, where we're going to the same place or the same location multiple times. I found this great visualization online that kind of shows you what it means to have a two-op method. As you can see, the path crosses originally from A, B, E, D, C, F, G, and that overlap between B and E and C and F is really kind of one thing we were running into constantly as we were doing this data analysis. And two-op would make it so the path would be changed. The algorithm would really emphasize there's no overlap. It goes A, B, C, D, E, F, G, so there's not that overlap between these 4 points. And using that algorithm, we really applied it to this data set in the 125 unique cities because we felt that would most improve our efficiency. We decided to use R, which you'll see on the next slide. As you can see, we really tried to first load in the data, then we created a distance matrix, then we created a TSP object, and finally we plotted it using Tor. The way we did this was I was able to find a source online that had a TSP meta kind of package that you could download with R. It would walk you through exactly how to use the process, how to use the package. As you can see, we read the file in, we would create a coordinate matrix, we created a distance matrix showing the distance between each different location, each 125 city to each of the others. We ran a solver, and finally we decided that this was going to be our perfect method, and after running it multiple times, we ended up with a final value of 663 miles. Once we hit 663 miles as the total distance traveled for the Gamecock drone service, we decided to run it 7 more times to make sure that was the optimal route and to kind of visualize the path that we took. Using R and using the plot function, you're able to see this perfectly embodies what a 2-op system and 2-op algorithm looks like. There's no overlap, there's not that constant going over the same place twice as you saw with the cluster and nearest neighbor method. And this method really gave us our most optimal solution of 663 miles, and therefore we believe Gamecock drone service should use the 2-op method using R for the data rather than nearest neighbor or cluster analysis. I want to thank you for this opportunity to do this drone route optimization project. Once again, we are Team Microsoft Bestxcel.